definitely. So I guess first, normally, I will model something in CAD and get it pretty well reinforced, but there are limitations with CAD. For instance, it's hard to model a hexagonal structure along the entire surface, like I did in Grasshopper. And there's other kinds of structures. There's literally a plugin, and I can go stick in all kinds of different structures or all kinds of different patterns that are possible reinforcement patterns, and they're not. And these are just sort of stupid patterns. These are just like a space frame. It's not like an optimized structure. And so, and then this, depending on how I want to use it, could still be a CAD software. This one command turns it into a mesh. If I was just to pipe it, for instance, so for example, oops, all right, so if I just scroll over here and make just a regular old surface, I can stick this surface in here. It'll take a second to process. Let's make that number smaller so it's just faster. So like that is now a mesh. It's got a kind of a nasty looking, this mesh is not fantastic, but I can literally stick that same surface into here, and this will give me just a bunch of curves, just regular NURBS curves that I could then pipe. And so like the pipe is heavy. That's the one issue. Like NURBS is traditionally a little bit heavier than meshes, and so like for instance, it's going to be a 1 millimeter pipe because it defaults. But so we're still in NURBS if I bake it out of Grasshopper, which is just a technical term. But like if I take it out, I get a nice cell. That's a closed poly surface. If I look at it in shaded view, works perfectly fine. I just like meshes because they're lighter and faster to work on, and so I can update it a lot quicker. And so once I've got this, but I mean I can literally, so that's a hexagonal structure. Let's make it like, for instance, I don't like hexagons. I like diamonds. And this is me not really trying to hit a particular, one second, it'll update to diamonds very quickly. And this surface is a flat surface. It can be applied to any surface. And so very quickly that'll work. And so, but now, if I want a Boolean, like, let's see how many pipes there are. There are 41 different pipes in here, or 41 different objects, and I want to Boolean it onto this surface. That might take a long time. It might crash the software. There's a lot of possible things that it could happen. And particularly, that's not a very complicated, that's just a surface. I might end up with like 50,000 pipes that I could click Boolean, and then it would take all night or all day to like stick together in the end. And so where if I just bring those into ZBrush or Mesh Mixer, or I'm trying to think of other ones like Magix or anything that can handle meshes, once you're out of the NURBS surface, you of course lose those nice NURBS portions of it, but you can then very quickly handle large quantities of information. And so let's just take this for example. Offset surface, flip all. Yeah. So now we've got I think a 1 millimeter thick surface with 1 millimeter pipes reinforcing that structure. So now it's basically the equivalent of, or I guess since the pipes are split half. So this is basically the equivalent strength sort of a 1.5 millimeter thick surface. And so maybe you've discovered that if you're printing an SLA, for instance, that was one of our more recent examples, we were basically printing those eggshells from earlier. And when we were using 0.3 millimeter thick walls on those eggshells, during the cleaning process, the alcohol would distort the part slightly, and we were getting some unuseful characteristics, some warping on the surfaces on our big flat surfaces. And so what I did with the geometry, rather than trying to fine-tune our cleaning process and spending forever like seeing if we can do it and failing at cleaning over and over again, I just went in and reinforced a couple of surfaces on the part and made them a little bit thicker. By literally doing that, I think I used hexagons instead of diamonds, but very quickly just reinforced the surface, and that solved the problem 100%. And because I'm not just thickening the part, so like for instance, I could make this whole sheet, like if I make exactly this same sheet over here, that's the same thickness. Let me explode it and start over. Not start over, but I want this bottom one. And offset this, offset surface. The other one was 2, so 2.5. So the volume of this part is 8,680 cubic millimeters. The volume, let's see if I can get the volume of all of that all at once. For 42, oh, that's right, it's double calculating things. So here, let me merge these all in ZBrush together very quickly. And so also, for instance, on each one of these diamonds, there's overlapping surfaces right here. That's the edge of one diamond. If I click on that diamond, they share a surface, so a lot of times things like efforts get duplicated, which will cause really weird things to happen when you try and Boolean union everything together, because you've now got coincidental surfaces. And I know Rhino doesn't like that, at least. And so if I export these out to ZBrush, and it's just as an OBJ or an STL or anything. I know normally people hate working with STLs, because once it's an STL, it's basically the end of the workflow, but it doesn't have to be the end of the workflow. You can continue working on things for a while afterwards. So here we've got this surface. Literally I have to weld all the vertices on it because it's now a mesh, and then let's retopologize it. Retopologize. And so I don't have to fill it everything, but I like to fill it everything. So let's move. So now we've got this nice reinforced structure here. I'm not even going to decimate it for the sake of this. Let's call it number 3. Hide that guy, file, import. Bring it back into Rhino. And so now if I get that's weird, I guess I do have to decimate it. And the decimation basically, again, retopologizes it, but makes it easier to work on. I can create, in these mesh modeler programs, a poly count of like 10 million polys, which would kill basically any other software. But in a lot of like Maya and ZBrush can handle them just fine. And so you can go crazy on the details you want to add, and you can add like, say, a snake skin texture to the inside of it, or maybe a shark skin texture at depending on the resolution of your printer. You could add like a near to scale shark skin texture across the inside of your part to reduce the amount of bacteria that could build up on the inside of, say, what are they called? Like a surgical tube that normally would run blood, or some sort of part that processes some fluid from the human body. You could add a texture on there that would basically, like just the geometry itself would reduce the likelihood of it growing bacteria. And so let me import this part. ZBrush, okay. Nope, that was the wrong part I imported. Call it 3. Still the wrong part. Export 4. I'm really bad at naming stuff with numbers. I apologize. It makes it really hard to search things later. So this is now 8,184 cubic millimeters versus 8,680 cubic millimeters. So this is an overall like mass reduction of this part of, I'm not going to do the math, of 600 cubic millimeters, approximately 500 cubic millimeters. But we've still got the same thickness. Like if I set them on top of themselves, or I bring them over, they're both, so my part's even actually slightly thicker, but still has a smaller volume. And so that is possibly good if your goal is to have less volume, which is the equivalent of less material, so less weight, but same strength. That's a very good way of doing it, if that makes sense.